Hello friends, in the last video we have seen some very important definition from linear programming problem. Even we have completed first 3 examples from exercise 7.4. So all of you are most welcome to my YouTube channel Maths by Samit Deshmukh. So now we are starting example number 4th. Now the method which you have applied in first 3 example, exactly same method we have to apply to solve the example number 4th. All the example in this exercise we have to solve using same method. So in this example we have to maximize this objective function subject to the constraint. If we will focus on the constraint, check how many constraints are given to us. Here value of x is greater than 0 is one constraint and value of x is less than or equals to 3 is two constraint. Means this expression is combination of two constraints. In the same way here value of y is greater than or equals to 0. So this is first constraint and value of y is less than or equals to 3 is second constraint. Here also they have combined two constraints and the last fifth constraint is x plus y is less than or equals to 5. So first consider the constraint x is less than or equals to 3, then consider the constraint y is less than or equals to 3, and lastly x plus y is less than or equals to 5. And we know that if value of x is greater than or equals to 0 and value of y is greater than or equals to 0, means these are called as non-negative constraint or non-negative restriction. In this case solution set lies in which quadrant? First quadrant. Because value of x and y are non-negative, this condition is satisfying by all the point in what? First quadrant. Now to draw this line, so from this constraint we will get what? Which line? X is equals to 3, here we will get y is equal to 3, and here x plus y is equal to 5. Means to find out solution set of this constraint, first we have to draw these lines. So if you observe first line, its equation is in the form of x is equals to constant, means this line is parallel to which axis? Parallel to y axis, and passes through the point. Here take x is equal to 3 and take any value of y coordinate, but take y coordinate is equal to 0, so that easily we are able to find out position of this point on what? X axis. So we can say that this line passes through the point, which point? 3, 0 and parallel to y axis. And if you observe this constraint, which sign appears? Less than or equals to. If less than or equals to appears, at that time which region is our solution set? So region on origin side will be our required solution set. So origin side region will be our solution set if less than appears in the given constraint. In the second constraint, y is less than or equals to 3, first we have to draw the line y is equal to 3. So y is equals to constant is a line parallel to which axis? X axis. And let us try to find out coordinate of one point on this line. Take y coordinate is equal to 3 and take any x coordinate, but easily to find out the position of the point we are taking x is equal to 0, means this point lies on y axis. So this line passes through the point 0, 3 and parallel to y is equal to constant, means parallel to x axis. Here also less than or equals to appears, so that's why we can say that our solution set lies on origin side. Now lastly, observe the last line, x plus y is equal to 5. In this case first substitute y is equal to 0. So to find out value of x coordinate, if y becomes 0 x will be equals to 5, or if x becomes 0 y will be equal to 5. Means coordinate of 2 points on the line are 5, 0 and 0, 5. In this case also less than or equals to appears in this constraint, means for this constraint also origin side part will be our required region, or we can say that our solution set lies on origin side part. Now x is greater than 0 and y is greater than 0 is given to us. At that time we know that solution set lies in first quadrant. So now let us try to draw the first line which passes through the point 3, 0 and parallel to which axis? Parallel to y axis. So our first line passes through the point 3, 0 and parallel to y axis. So in this way we have constructed our first required line, x is equals to 3. Now observe the second line, y is equals to 3. This line passes through the point 0, 3 and parallel to x axis. So draw this line. So our next line is y is equals to 3. The third line passes through the point 5, 0 and 0, 5. So draw a line passing through these 2 points. What is the equation of this line? Equation of the line is x plus y is equals to 5u. So once all the lines are constructed, then observe the signs in the constraint. All the signs are less than. Less than means for all these constraint, origin side part will be our solution side. For the first line also origin side part, for the second line also origin side part, for the third line also origin side part. So here easily we can observe that the set of all these points, means the shaded portion, is nothing but our required feasible solution or feasible region. So here we can say that shaded portion in the figure is the feasible region with the vertices. Vertices means what? Corner point. Let us denote first vertex by O, second vertex by A, third vertex by B, fourth vertex by C, and the last vertex by D. So with the vertices O, A, B, C, D. Now we are trying to find out coordinate of these vertices, where O means what? Origin. We know that coordinate of origin are 0, 0. A lies on which axis? X-axis, so its y coordinate is 0, and here easily we can observe that the value of x coordinate will be equals to how much? 3. Now try to find out coordinate of point B. So to find out coordinate of point B, we can easily observe that it lies on which line? X is equals to 3, means here x coordinate is 3, and even this point lies on this second line, x plus y is equal to 5. But x coordinate is already known to us 3, plus 3 on this side will become minus 3, 5 minus 3 is 2, means y coordinate will be equals to 2. Now find out coordinate of vertex C. So this point lies on which line? Y is equal to 3, means here y coordinate is 3. Even this point lies on this line also, so the coordinate of this point satisfies this equation also. If I am substituting y is equal to 3 plus 3 on this side will become minus 3, and what value of x we are getting here? 2. Lastly, let us try to find out coordinate of vertex D. D is a point on y-axis, so that's why we can say that x coordinate is 0, and here we can observe that y coordinate will be equals to 3. Once the coordinate of all the vertices are known to us, then consider our objective function. So given objective function is, what is the given objective function? Z is equals to 10x plus 25y. Now what is the method? Then last step is to find out value of objective function at all these 5 vertices. Now let us try to find out value of this objective function at vertex A, then value of this objective function at second vertex B, then third vertex C, fourth vertex D, and lastly the value of this objective function at fifth vertex O. So now finding the value of objective function at the vertices means substituting the value of coordinate of these vertices in this objective function. So keep 10 as it is. For the point A, what are the coordinate? 3, so replace x coordinate by 3 and y coordinate by what? 0. So this term will become 0, and here 10 3s are 30. In this way we have got the value of objective function at vertex A. Then find out value of objective function at vertex B. 10 into x is 3 plus 25 into 2, so which is equal to here 30 plus 50 will be equals to 80. Then find out value of objective function at vertex C, where its coordinates are 2, 3, so 25 into 3. Let us see what we will get. Here we will get 20, and here we will get 75. 75 plus 20 will be equals to 95. Then find out coordinate at vertex D. So where coordinate of vertex D are 0, 3. So 25 into 3 will be equals to 75 here, because first term becomes 0. Now lastly find out value of objective function at vertex O. Its coordinate are 0, 0, so plus 25 into 0, so will be equals to 0. So 10 into 0 plus 25 into 0, both the terms will become 0, and addition will be equal to what? 0. So here we have to maximize the objective function. So check that at which vertex we are getting maximum value. Here easily we can observe that 95 is the maximum value of the objective function. That's why we can conclude that therefore maximum optimum solution is how much? 95, and this solution we have got at x is equals to, in this case, what is the value of x? X is equals to 2 and y is equals to what? 3. So in this way we are solving the linear programming problem graphically. Now let us try to solve the example number 5th. In the example number 5th, we have to maximize this objective function subject to first, second, third, fourth, fifth, means subject to 5 constraint, and we have to find out maximum optimum solution. So first we are considering the given constraint. First constraint is x plus 4y is less than or equals to 24. Second is 3x plus y is less than or equals to 21, and last constraint is x plus y is less than or equals to 9. And the last two constraints are x is greater than or equals to 0 and y is greater than or equals to 0, which conclude that solution set lies in first quadrant. So here from this constraint, first find out equation of line. From the second constraint, what line we are getting? 3x plus y is equals to 21, and here we will get x plus y is equals to 9. Find out coordinate of 2 points on this line. If I am substituting y is equal to 0, here x will be equal to 24. If I am substituting x is equal to 0, 4y is equal to 24 implies that y is equal to what? 6. Now from here substitute y is equal to 0, 3x is equal to 21 means x will be equal to 7, and if I am substituting x is equal to 0, y will be equals to 21. Here if I am substituting y is equal to 0, x is 9 and x is equals to 0 implies that y is equals to 9. So coordinate of 2 points on the line first are 24, 0 and 0, 6. On second line are 7, 0 and 0, 21, and lastly 9, 0 and 0, 9 are the coordinate of 2 points on this line. Now for all these constraint, which sign appears less than or equal to, less than or equals to, means for all these lines origin side part will be our solution set. Once the coordinate are known to us, let us try to construct our lines. Now observe that first line passes through the point 24, 0 and 0, 6. So passes through these 2 points. So draw a line passing through the point 0, 6 and 24, 0. And what is the equation of line first? Equation of line first is x plus 4y is equals to 24. Now observe the second line. Second line passes through the point 7, 0 and 0, 21. This is the position of 0, 21, and 7 lies somewhere in between what? 6 and 9. So once the position of 2 points is known to us, draw a line passing through these 2 points. Once the line is constructed, so write down the equation of line here. Equation of line is 3x plus y is equals to 21. Lastly, draw the last line x plus y is equal to 9, which passes through the point 9, 0 and 0, 9. So draw a line passing through these 2 points. So here equation of this line is x plus y is equals to 9. Now for all these constraint, which sign appears less than or equals to, means for all the three line, for first line, for second line and for the third line, origin side part will be the solution set. This is the origin, means origin side part will be the solution set. So here we can say that the shaded portion in this figure represent the feasible solution, and this region is called as what? Feasible region. So shaded portion is the feasible region with vertices. Denote the vertices by capital letter O, A, B, C and D. Means corner point of this convex polygon is nothing but what? Vertices. This convex polygon is nothing but what? Our feasible region. So first vertex we have denoted by O, where its coordinate are 0, 0. Second vertex is A, where its coordinate are 7, 0. Then B. B is the point lies on which two line? B is the point lies on the line x plus y is equal to 9 and 3x plus y is equal to 21. Means to find out coordinate of this point, we have to solve these two equations simultaneously. If we are taking their subtraction, 3x minus x will be equal to 2x, y will get cancelled, and on this side 21 minus 9 will be equals to 12, which implies that x will be equal to what? 6. So in this way we have got x coordinate. Once x coordinate is known to us, substitute x is equal to 6. So what value of y we will get? 9 minus 6 will be equal to 3. Then find out coordinate of vertex C. C is the point of intersection of which two line? X plus y is equal to 9 and x plus 4y is equal to 24. If we are taking difference, x will get cancelled. 24 minus 4y minus y will be equal to 3y, and on this side 24 minus 9 will be equals to 15. So implies that x is equals to 5. Value of x is known to us, x coordinate is 5. To find out y coordinate, substitute this value of x is equal to 5 here, plus 5 on this side will become minus 5. So 9 minus 5 will be equal to 4. And lastly, find out the coordinate of last vertex D, where D is a point lies on y-axis, so its x coordinate is 0, and here we can observe that y coordinate will be equal to 6. So once the coordinate of all the vertices are known to us, then consider the objective function. So once the objective function is considered, then find out the value of this objective function at all these vertices. Means value of objective function at vertex O, then at vertex A, B, C and what? D. So let us try to find out coordinate of value of objective function at all these vertices. What are the coordinate of origin? 0, 0. So replace x by 0, y by 0. So what we will get here? 0. Then substitute here coordinate of point A, 7, 0. So replace x by 7 and y by 0. So here 7 3s are 21 because second term is becoming 0. Observe the coordinate of B, 6, 3. So 3 into 6 plus 5 into 3. So hope all of you are getting it. We are just replacing x by x coordinate and y by y coordinate. Here we will get 18 and here we will get 15. 18 plus 15 will be equal to 33. Then find out coordinate at value of objective function at vertex C. So here 3 into 5 plus 5 into 4. So here we will get 15 and here we will get 20. 20 plus 15 will be equal to 35. Lastly, we are finding value of objective function at last vertex D. So where x coordinate is 0 and y coordinate will be equals to 6 and 5 6 are 30. As a stand, we have to maximize the objective function. Check what is the maximum value of this objective function, that is 35. So we can conclude that maximum optimum solution. So maximum optimum solution is 35 at x is equal to, what is the value of x here? 5 and y is equals to what? 4. In this way we have got maximum optimum solution. Now let us try to solve the question number 6 from this exercise 7.4. If you'll observe in this example, we have to minimize the objective function subject to the given constraint 1, 2, 3, 4. Total 4 constraints are there. So first consider first constraint, then consider second constraint. So now to find out solution set of these constraints, first you have to construct the line. From the first constraint, what equation of line we are getting here? 5x plus y is equal to 5, and from second constraint we will get x plus y is equal to 3, and x and y are greater than or equals to 0, means these are non-negative values. So we can conclude that solution set lies in what? First quadrant. Since the method to solve all the example is exactly same, so some common part already I have written here. So now to find out coordinate of 2 points on this line, first substitute y is equal to 0. If I am substituting y is equal to 0, this term will become 0, 5x will be equals to 5. So simplifying it, we will get x is equals to what? 1. Now substitute x is equals to 0. If I am substituting x is equal to 0, what value of y we will get here? 5. So we can say that the line first passes through the point 1, 0 and 0, 5. In this expression, which sign appears greater than or equals to, and we know that when greater than or equals to appears, at that time we can say that non-origin side part will be our required solution. non-origin side, means region on the non-origin side will be the solution set of this constraint, or solution set of this constraint lies on what? Non-origin side part of this line. Now for second line, find out coordinate of 2 points. First substitute y is equal to 0, we will get x is equals to 3. If I am substituting x is equal to 0, we will get y is equal to 3. Means second line passes through the point 3, 0 and 0, 3. In this expression also greater than or equals to appears. And we know that when greater than or equal to appears, at that time non-origin side region will be our required solution set for this constraint. And already we have written that when x and y are greater than or equals to 0, solution set lies in first quadrant. Now let us try to construct the first line which passes through the point 1, 0 and 0, 5. So once the coordinate of 2 points on the line is known to us, draw a line passing through these 2 points. So in this way we have constructed first line whose equation is 5x, plus y is equals to 5. Now let us try to construct the second line which passes through the point 3, 0 and 0, 3. Coordinate of 2 points on this line are known to us, so draw a line passing through these 2 points. Once the line is constructed, then write down that equation of line x plus y is equals to 3. Now our solution set lies in what? First quadrant. And for both the constraint, which sign appears greater than or equals to, means we can say that our solution set lies in which quadrant? First, our solution set is non-origin side. For both the lines, non-origin side means for this line also non-origin side and for this line also non-origin side. So and our solution set lies in which quadrant? First quadrant. So here we can observe that the shaded portion is the set of all point which satisfies all the given constraints. So our solution set lies in what? First quadrant. So we are not going outside the first quadrant, and for both the line, non-origin side part will be the solution set. Once the solution set is known to us, then set up all such point which satisfies all the constraint is called as what? Feasible solution, and this region is called as feasible region. So here we can say that shaded portion in the figure is feasible region with the vertices. Let us denote the vertices by A, B and C. So here 3 vertices we have got here, so which we have denoted by A, B, C, where with vertices A has coordinate 3, 0. Let us try to find out coordinate of vertex B and then coordinate of vertex C. So here B is the point of intersection of these two lines. So to find out coordinate of point B, we have to solve these two equations simultaneously. Here we can observe that coefficient of y are same. If we are taking difference of these two equations, term of y will get cancelled, and see what we'll get. 5x minus x will be equals to 4x, and on this side 5u minus 3 will be equals to 2. So x will be equals to 1 by 2. So x coordinate is known to us 1 by 2. If we are substituting x is equals to 1 by 2 here, plus 1 by 2 on this side will become minus 1 by 2. 3 minus 1 by 2 will be equal to 5 by 2. Means value of y coordinate is also known to us. Lastly, let us try to find out coordinate of point C. And coordinate of point C. C is a point on which axis? Y axis. So that's why we can say that its x coordinate is 0 and y coordinate will be equal to 5. Once coordinate of all the vertices are known to us, then consider the objective function. What is the objective function? Z is equal to 7x plus y. Now we are finding value of this objective function at all the vertices, means at vertex A, vertex B and vertex C. What is the objective function here? 7x plus y. So 7x plus y, 7x plus y, means remaining part is just to substitute the value of coordinate. For the point A, coordinates are 3, 0. Here y means what? 0. So which is equal to 21. Then substitute the coordinate of point B, which is equal to 1 by 2. X coordinate is 1 by 2 and y coordinate is what? 5 by 2. If you will observe, denominator of both the terms are the same. What is denominator? 2. So we are taking addition of numerator. 6 plus 7 will be equals to 12. 12 upon 2 will be equal to what? 6. Then substitute the coordinate of vertex C 0, and here y coordinate is phi u, so will be equals to phi u. So in this way we have got the values of objective function at all these vertices. Check which is the minimum value, because question is to find out minimum optimum solution. So here we can observe that value is minimum at which vertex C, and what is that minimum value? Phi u. So we can say that minimum optimum solution is phi u at x is equals to 0 and y is equals to phi u. In this way we are solving linear programming problem graphically. Now observe the example number 7th. In this example we have to minimize the objective function subject to constraint 1, 2, 3, 4, 5. Total 5 constraints are there. So meaning of last 2 constraint is what? That solution set lies in first quadrant. So here already we have written that x and y are greater than or equals to 0. At that time we can say that solution set lies in first quadrant. So we have considered here first constraint, so from which we will get one line 2x plus y is equal to 7. From the second constraint, or to find out solution of second constraint, we have to construct first line, and using inequality later on we are able to check which part will be the solution set. Here what is the equation of line? Y is equals to 2. Now find out coordinate of 2 point on the line first. If I am substituting y is equal to 0, so 2x is equal to 7 implies that x is equal to 7 by 2 means we can say that 3.5. If I am substituting x is equal to 0, then y will be equal to 7. In this way we have got coordinate of 2 point on this line 3.5, 0 and 0, 7. Now try to find out coordinate of 2 point on the line second. If I am substituting y is equal to 0, here what we are getting? 2x is equals to 15. So x is equal to 15 by 2. 15 by 2 means we can say that 7.5. So our first point on the line has coordinate 7.5, 0, and to find out coordinate of second point, substitute x is equals to 0. So we will get 3y is equal to 15 means y is equal to 15 by 3 will be equals to 5. So here 0, 5 are the coordinate of second point. So in this case what is equation of line? Y is equals to constant. At that time line is parallel to x-axis and passes through the point. Y coordinate is 2. So take x coordinate is equal to what? 0, because we will require only one point on this line, because a point is known to us. Draw a line passing through this point parallel to x-axis. So this line passes through the point 0, 2 and parallel to x-axis, If you will observe for all the constraint, which sign appears? Greater than or equals to, and we know that if greater than or equals to appears, at that time non-origin side part will be the solution set, or we can say that solution set lies on non-origin side part. Now let us try to construct these lines. So we can observe that here first line passes through the point. Which point? 3.5. 3.5 lies somewhere in between 3 and 4, and second point is 0, 7. So 0, 7. So once the coordinate of 2 point on the line is known to us, draw a line passing through these 2 points. And here what is the equation of line? Equation of first line is 2x plus y is equals to 7. Now let us try to draw the second line, which passes through the point 7.5, which lies somewhere in between 7 and 8. 7.5 and 0, 7.5, 0 and 0, 5. So coordinate of 2 point on the line second is known to us. Draw a line passing through these 2 points. Then write down equation of the line. What is equation of second line? 2x plus 3y is equals to 15. Now observe the third line, which passes through which point? 0, 2. So 0, 2 is the point on y-axis, and our line is parallel to x-axis and passes through these 2 points. This point. So draw a line parallel to x-axis and passing through this point. And what is the equation of this line? Equation of this line is y is equals to 2. Now we can observe from these signs greater than or equals to means for all the lines non-origin side part will be the solution set. Means for this first line also non-origin side, for the second line also non-origin, and for the third line also non-origin side part will be the solution set. So here we can say that the shaded portion is our required what? Solution set. In this way we are able to find out solution set of all the given constraint. The shaded portion in the figure is nothing but our feasible solution. Once the feasible solution is known to us, denote the corner point by capital letter, which are nothing but vertices. So A, B, C are the vertices of this feasible region. So first write down shaded portion in figure is feasible region with vertices. Let us try to find out coordinate of first vertex A. So here we can observe that y coordinate is 2, and to find out x coordinate, so this point also lies on this line. So make the use of equation of this line. If I am substituting here y is equals to 2 into 3, 6 plus 6 on this side will become minus 6. 15 minus 6 will be equals to 9, and x will be equals to 9 by 2 means will be equals to 4.5. So coordinate of vertex A is known to us. Then find out coordinate of second vertex B. So here we can observe that B is the point of intersection of these two lines. If you will observe equation of these two lines, coefficient of x are what? Same. So take the difference of these two equation, term of 2x will get cancelled, 3y minus y is equal to 2y, and on this side 15 minus 7 will be equals to 8. So y will be equals to what? 4. Once the value of y is known to us, substitute y is equal to 4, plus 4 on this side will become minus 4, 7 minus 4 will be 3, 2x is equal to 3 means x is equals to 1.5. So coordinate of vertex B is also known to us, and coordinate of third vertex C. So this point lies on which axis? It lies on y-axis. So x coordinate is 0 and y coordinate is here 7. Once the coordinate of all the vertices are known to us, then consider the given objective function. So here given objective function is, what is the given objective function? Z is equals to 8x plus 10y. Now we are trying to find out value of this objective function at all our vertex. First vertex is A, then find out the value of this objective function at vertex B, and lastly find out the value of objective function at vertex C. So substitute the values of coordinate of point A in this objective function. What is x coordinate? 4.5 and y coordinate is 2. Let us simplify it. 45 8s are 360, but decimal point is before one digit, so 360 means we will get 36, and 10 2s are 20. So 20 plus 36 will be equals to 56. Now find out the value of objective function at vertex B. 8 into x. X is what here? 1.5 plus 10 into 4. So which is equal to, let us check what value we are getting. 15 8s are 120, decimal point is before one digit means here we will get 12, and 10 4s are 40. So 40 plus 12 will be equals to 52. Lastly, let us try to find out value at vertex C. So 8 into, see what we'll get, x coordinate is 0 plus 10 into 7. So first term is 0, and here 10 into 7 will be equals to 70. At this time we have to minimize the objective function. Check which is the minimum value. Minimum value is 52. So that's why here we can say that minimum optimum solution is 52, which we are getting at which vertex? At vertex B, where value of x is equals to, at x is equals to 1.5 and y is equals to, and what is the value of y coordinate here? 4. In this way, using graphical method, we are solving the linear programming problem. Now see the last example from this exercise. In this example number 8, we have to minimize the objective function subject to given constraint. Total 5 constraints are given to us. So we have considered here first 3 constraint, and meaning of last 2 constraint is that solution set lies in what? First quadrant. So here from the first constraint, or to find out solution set of first constraint, first construct the line x plus 4y is equal to 4. From this constraint, equation of line is 3x plus y is equal to 3, and lastly x plus 2y is equal to 3. To construct this line, try to find out coordinate of 2 points on the line first. First substitute y is equal to 0, we will get x is equals to 4. If we are substituting x is equal to 0, 4y is equals to 4 means implies that y is equals to 1, means we can say that line first passes through the point 4, 0 and 0, 1. Now let us try to find out coordinate of 2 points on the line second. So substitute y is equal to 0, we will get x is equals to 1, because 3x is equal to 3 implies that x is equals to 1. And if we are substituting x is equal to 0, y will be equals to 3. Here if I am substituting y is equal to 0, x will be equals to 3, and if we are substituting x is equals to 0, 2y is equal to 3 means y is equal to 1.5. So coordinate of 2 points on the line second are 1, 0 and 0, 3, and coordinate of 2 points on the line third are 3, 0 and 0, 1.5. And if you will observe for all the 3 constraints which sign appears greater than or equals to, means we can say that solution set lies in first quadrant. Now let us try to construct these lines from the using the coordinate of the point. So first line passes through the point 4, 0 and 0, 1. So coordinate of 2 points on the line first are known to us. So just simply draw a line passing through these 2 points. So equation of first line is x plus 4y is equals to 4. Now observe the coordinate of a point on the line second, 1, 0 and 0, 3. So position of 2 points on this line is known to us. Draw a line passing through these 2 points. And here equation of the line is 3x plus y is equals to 3. Now observe the third line which passes through the point 3, 0 and 0, 1.5. 1.5 lies somewhere in between 1 and 2. So once the position of 2 points on the line is known to us, draw a line passing through these 2 points. So in this way we have got third line also, whose equation is x plus 2y is equals to 3. Now for all these inequation greater than appears means non-origin side part will be the solution set. For this line also non-origin, for second line also non-origin, and for third line also non-origin side part. So easily we can say that the shaded portion in this figure is nothing but feasible solution, or we can say that feasible region. So in this way we have got the feasible solution, means set of all the point which satisfies all the constraint. Now denote here the corner points by capital letter, which are nothing but vertices of this feasible solution. Let us denote first vertex say by A, second vertex by B, third vertex by C, and fourth vertex by D. Now our aim is to find out coordinate of these vertices. So here we can say that shaded portion in figure is feasible solution or feasible region with vertices. So first vertex we have denoted by A, and here easily we can observe that its coordinates are 4, 0. Then find out coordinate of second vertex B. Here we can observe that B is the point of intersection of these 2 lines. So to find out coordinate of this point, we have to solve these 2 equations simultaneously. If you'll observe here, coordinate coefficient of x in both the equations are same. So we are taking difference of these 2 equations. If we are taking difference, x will get cancelled. 4y minus 2y is 2y, and on this side 4 minus 3 is equals to 1, which implies that y is equal to 1 by 2. So y coordinate is known to us 1 by 2. Substitute this value of y is equal to 1 by 2 to, in equation, in any one of these two equation, if I am substituting y is equal to 1 by 2, 2 will get cancelled, here will get 1, plus 1 on this side will become minus 1, 3 minus 1 will be equal to 2. In this way we have got coordinate of point B. Then find out coordinate of vertex C. Now C is the point of intersection of these two lines. To find out this coordinate of point of intersection, we have to solve these two equations simultaneously. So here coefficient of x and y are not same. To make it same, I am multiplying to first equation by 2. So here we will get 6x plus 2y. On this side also we will get 6. Now if we are taking difference of these two equation, so what we will get, 6x minus x will be equals to 5x, 2y will get cancelled, and 6 minus 3 will be equals to 3, so x is equal to 3 by 5. So x coordinate is known to us 3 by 5. To find out value of y coordinate, substitute this value of x is equal to 3 by 5 in this equation. So 3 by 5 on this side will become minus 3 by 5. So what we will get, 2y is equals to 3 minus 3 by 5. 3 minus 3 by 5. 5 3s are 15. 15 minus 3 is 15 minus 3 is 12. 12 by 5 is the value of 2y. So which implies that y is equal to, if I am dividing both sides by 2, so here 2 will get cancelled and on this side we will get 6 by 5. So y coordinate will be equal to 6 by 5. This is our rough work, not necessary to solve these two equations simultaneously and then find out the coordinate. So perform this operation in rough. Otherwise you are able to perform this operation here also, but you are able to avoid that calculation in the solution. You are able to perform it in the rough work also. So coordinate of 3 vertices are known to us. Lastly, let us try to find out coordinate of vertex D. So here we can observe that point lies on y axis, so its x coordinate is 0 and y coordinate is 3. Once the coordinate of all the vertices are known to us, then consider the objective function. So given objective function is, what is the given objective function? Z is equal to 6x plus 21y. Now we are finding the value of our objective function at all these 4 vertices. First find out the value of objective function at vertex A, then at vertex B, then find out the value of objective function at vertex C, and lastly the value of objective function at vertex D. So here what we are getting, what is the objective function? 6x plus 21y. So again 6x plus 21y. So now we are substituting the coordinate of vertex A, which are nothing but 4, 0. So 6 4s are 24 plus 0 will be equals to 24. Now substitute the coordinate of vertex B, which is nothing but 2 and 1 by 2. So here we will get 10 and 21 upon 2 will be equals to 10.5. So 12 plus 10.5 will be equals to 22.5. Again find out value of objective function at vertex C. Coordinate of vertex C are, so what are here coordinate of vertex C? 3 by 5 and 6 by 5. So here we can observe that denominator of both the terms are same. What is the denominator? 5. Now simply take the addition of numerator. So here 6 3s are 18 and here 21 into 6. 6 1s are 6 and 6 2s are 12. So which is equal to 8 plus 6 is 14. So again here we will get 4, 144. 144. Let us try to perform this division. 5 2s are 10. So here we will get 2. Again remaining term is 44. 44 means 8s are 40. Again remaining term is 4. So 4 means 40 means will be equals to 8. 40 means 8. 28.8. Perform this division. So all of you are know how to find out the division. So lastly find out the value of objective function at the last vertex D, where its coordinates are 0, 3. So 6 into 0 plus 21 into 3. So 21 3s are 63. In this way we have got the value of objective function at all the vertices. As is stand in this example, we have to minimize the objective function. So check which is the minimum optimum solution. Minimum optimum solution is 22.5. So minimum optimum solution is 22.5, and this minimum optimum solution we are getting at which vertex? B, whose coordinates are 2 and 1 comma 2. So we can say that at x is equals to 2 and y is equals to 1 by 2. So in this way we have solved this example graphically. So we have completed this exercise 7.4. In the next video we are starting example from miscellaneous exercise.